Cool. We are all on the 27th of April, and we are, what is the class number? 13th class, right? Okay. So we have created our Snowflake account in the last class. We loaded some data manually, right? So we'll just do a quick review of what we did in the last class, and from there onwards, we will get started. And today's class, we are going to focus on all the different type of loading mechanisms, okay? Now I'm going to share my screen. I'm going to share my second desktop, share. Fine. So in Snowflake, there are two ways of bringing data into Snowflake. Number one is a bulk load. So what is a bulk load? Bulk load is nothing but a mechanism through which you load loads of data with a single command. So that means for every record, you don't fire a single insert statement. What you do is you write all your records in a file, and then you load the file at once. So that's bulk load. Now, under bulk load, there are two ways you can do a bulk load. One, by keeping your file from on an internal stage. Now, what is a stage? Stage is nothing but a storage location. It's just a directory in where you can save your files. Now, within Snowflake, you can create internal stage. Though in the background, it is creating the same S3 location, but it is all governed by Snowflake, and nobody else outside of Snowflake can see those stage files, right? So that's your internal stage. The other thing is external stage. External stage is nothing but your data will reside in an external location, which is your S3. And from there, data is going to be loaded in your Snowflake. Now, last time we looked at how internal stage works, we did not work on external stage, right? Today we're going to, again, we'll see internal stages again, and we will start loading data using external stages as well. Now, again, the process of creation of internal stage and external stage, I will not show you on the slides because information on the slide may or may not be updated. The most right place or the most recent or the latest edition of all the syntaxes which are there on Snowflake will be always found on your documentation. So you should always go to your documentation and find it out. I'll also route you to the documentation while I get into the details. Next, what is Snowpipe? Snowpipe is a way to push data into Snowflake at near real time. Now, this is not real time. Real time means as soon as the data arrives, the data has to, or as soon as the data is created, the data will be ingested into Snowflake. No, that is not the case. This is near real time because this is faster than bulk, definitely faster than bulk load, this is definitely faster than loading data, or I'm not talking from the speed of, so when I say faster, I'm not talking from the speed of loading. I'm talking from the frequency of loading, right? So this is definitely faster than bulk load frequency, wherein you can bring in a file into Snowpipe and load that file into Snowflake automatically. So Snowpipe is a serverless service. Please remember, Snowpipe is a server. Now, this is a serverless service, right? So I can write the details over here. This is a serverless service. That means for this, you need not use the warehouse. So the consumption of credits on Snowpipe are very, very less, definitely. But again, it is all charged through credits. And, you will be able to pull information into or records into Snowflake using Snowpipe at near real time. So how does it work? We will again get into the documentation. There's a nice picture over there. So I don't want to copy that picture again into a slide and show it to you. But on the documentation itself, we will see how nicely we can configure Snowpipe and work with Snowpipe. So we will get into a scenario wherein we will load data or we will upload a file into Snowflake. So we will upload a file into um, some S3 location, and Snowflake will automatically identify that yes, there is a file, and it will load the file. And this goes on and on and on and on and on. Now, there are few best practices of Snowpipe. We will talk about it. So serverless. Now, the other thing is we will have to talk about best practices of Snowpipe. Now, this is something which I'm going to talk about. Best practices of Snowpipe. Now, this is very, very crucial from the certification point of view, because during the certification, they will not ask you to build a Snowpipe, right? Because there's no development environment out there. They will ask you about the different ways you can create a Snowpipe and in which scenario you will use a Snowpipe and what are the different ways you can optimize a Snowpipe, right? So best practices of Snowpipe is something which we will definitely talk about today, right? Now, this is what is the plan for today's class. However, we will also try to see if I can touch upon um, let's say this is a snowflake table, right? So this is a snowflake table. So let me put it this way. This is a snowflake table. What I can do is from Snowflake, I can create another snowflake table by using something called, this is something which I don't know whether we will be able to cover today or not, or otherwise tomorrow we will cover before we start discussing about the project, because it's like, it will have this element. So this is called streams. We'll see at least if we can cover up the theory part today, so that tomorrow we will do the look at streams, and then we'll get into the blue remaining part and finally finish off discussing the project. Let's see. Cool. So let me go ahead and look at this. So this is the familiar screen. I think this is something which we all looked at in the previous class as well, right? So tutorial DB and this. So at the end of the class, I'm going to save this file as a SQL file and I can share it with you if you are interested. But anyway, I think you should all go to the documentation and pull information from there rather than looking at it from here, right? That should be your, that's how it should be done, right? Anyway, so first, what did we do? We created, okay, let me enlarge the screen a little more so that it is visible for you. So we created a database called tutorial DB. We are using that database because we have to use it first, or maybe you can, change it from here as well, wherein you select tutorial DB and then you select schema, right? Done. So at this point of time, if you see the database and the schema are all created. So what do you see? Data loading schema is created and there are a few content over there. We'll see that. Now, there is also stage created called internal stage. Now, if you remember, if you try to relate to this, I'll keep this small diagram open on the left hand, on the right hand side, so that, you can relate to this, right? I'll keep it open over here. I'm not sure how much it is visible, and then we go forward, right? We have created an internal stage. Now, at this point of time, if I do ls of the internal stage, you will see that there are few files which are already loaded. Contract.json, contract CSV, 1, 2, 3, 4, right? These are the files which have already been loaded. Now I will do something. If I go to our AWS data engineering class, uh, today is, oh, I think we should put it on the 12th. Over here, I'm going to put sample data for loading exercise. Okay. And over here, I'm going to push those content. I'm doing it at the same time because during the weekend, I keep forgetting, which I should not have, right? I'm going to put it in, oh, sorry, I should not be doing it here. I should be putting it inside, right? If I come over here, I should put it inside. Yeah, I'm just uploading all the files for you to play around. Right, fine. So our loading is done. Now, the very next question is, how did I load these files onto internal stage? Now, you would have seen that the easiest way to load the files into internal stage is to go to the tutorial, data loading, stages, and internal stage, and then you go ahead and add files, right? You can add the files. However, there is another easy way of doing it using the command prompt. So there is a put command. I'm not going to test it out, but I will request you to do it because again, not everything can be taught, right? I can I cannot show you each and every command and each and every syntax by doing it. So you have to be very, very attentive in looking at the coverage. Few of the things I'm going to show you, rather most of the things I'm going to show you, few of the things you will have to practice on your own. Now, there is a concept called put in Snow SQL, put command, yeah, put command documentation. So this works from your Snow SQL. This will not work from your Snow site because Snow site is a web-based tool. Snow site has no idea about your current folder structure, right? So what you have to do is you will have to use, let's take a sample. You see this? Put file local file path. So this is your local file path and then your stage name. This is how it works, right? And there are multiple parameters like auto compress, then I think there was another one, allow duplicates or overwrite equal to false or not. So something like that, right? So yeah, so put file, then the current file path, it says clearly upload a file named mydata.csv in temp directory to an internal stage. So from TMP to your internal stage, this is how you have to upload. Now, this is a method to upload files from internal stage, sorry, from your local directory, local to your SnowSQL. So wherever your SnowSQL is running, it can be a VM, it can be a server, it can be a local laptop. So from that local machine, if you want to upload anything to your internal stage, you can use SnowSite. However, if you do not have access to SnowSite or you want to do it repeatedly in a chain of command, then you cannot use it. You cannot use SnowPipe, right? Or SnowSite. You will have to create a DevOps channel or DevOps pipeline. And if you have to create a DevOps pipeline, you will have to put um, this particular file, put file. Yeah. I can show you something very interesting. I had created uh, uh, a DevOps pipeline in Python. Let me show it to you. Okay, give me a moment. Where did it happen? Where did it happen? I think I created it in a project where it was native application, right? Native app. tutorial, native webinar. Yeah. So this was a webinar which I was working on. So don't be scared. This is all not for you. In an end-to-end in a Python script, if you see, just look at this Python script. Yeah. Just look at this Python script. I'm just enlarging it. Huh? So this is how you create your end-to-end pipeline. So I'm creating a Snowflake connectivity. Then you see drop application, create application. So this is how you embed your Snowflake statements into a SQL. And you see upload all local files to stage. I'm doing it. So this is for a customer project. Uh, so upload all local files to stage. You see, put file manifest.yml. That's a different thing. At the rate database name or application package name dot package is nothing but a database. So package name dot schema name dot stage name. Overwrite equals to, you see this? Overwrite equals to true and auto compress equals to false, right? So this is what I was saying. So if you have to generally, when you create a DevOps pipeline, because see, this is a part of a real-time project, right? And I cannot ask the customer to go ahead and manually upload it. He will never do it. All he will do it, he'll just click a button. That's all. And that click of a button, all these steps will be done in sequence. Tuck, tuck, tuck. It's like, all these steps will be done in sequence. And finally, the application, it will be like, the application is deployed. Please switch over to Snowsite to view the application. So all the deployment tasks will have to be coded like this. And this is exactly how we will do our final project. Because that's how the industry expects you to work. And that's the only reason I keep asking you to write, try Python code, try writing your SQL. Because if you're not doing this, the interviewer on the other side will have a lot of expectations from you and you will not be able to fulfill, right? Uh, Fine, fair enough. So where were we? We were talking about stage, right? We'll go back to our projects, data loading. Right. At this point of time, you saw that we have 5 files. Now, if I go to the file.local, I think this table itself is not created. If you remember, last class, we created this table by uploading the file using the file upload wizard of Snowsite, right? And uploading a file, customer contact file. Now that is something which I'm not going to do it, right? Because anyway, you can go ahead and check it out. How did we do it? Now this contacts file, I think I did not upload the contacts file, right? I forgot to, come on, come on. Sample files, this customer file contact. Oh, no, no, no. This contact file also, I loaded it here. Fine, fair enough. Now, the next thing is we created an internal stage. So if I look at this particular stage now, do I have any data? Yes, I do have some data. So let's go ahead and truncate this table first. Yeah. See, there's a command called truncate table. What is truncate? Truncate means I am deleting everything from the table. Now, there's a what is happening is, yeah, what I was trying to tell you is truncate table name. Now, there are two things. Again, from a SQL interview perspective, note it down. There are two ways to delete data from a table. One is truncate command and the other one is delete command. Now, there's a difference between truncate and delete. Please read it out. Anyway, I'll tell you for a minute. Truncate deletes or truncate removes the data from the database logs which is at a much finer granularity, and delete it records, and it's like, delete will delete the record, one record after the other. So if you have, so let's say what you can do is you can load 1 million records in a table, and you truncate the table, and you record the time, how much it takes to truncate, or to truncate the table, and then you delete the records from the table and check how long it takes to delete the records from the table. You will see delete will take much longer time than truncate, because delete will actually remove the records one by one after the other. It's a sequential operation. And truncate is like, it's like, emptying a bucket. So delete is like, slowly empty the bucket, pour the water very steadily, and then it's like, at a constant rate, and finally the bucket is empty. And truncate is like, just reverse it all of a sudden, everything out, flush out suddenly, right? So that's the difference between delete and truncate. And I will not be surprised if this is an opening question for you guys. So I'm truncating the table, right? I'm truncating the table. At this point of time, if I do a select count star from contacts internal stage, it is empty. Now, what I'm going to do is I'm going to create a file format. Now, if you remember last time, we were not able, when we were about to close the class, we were not able to load the data. The primary reason was it was failing because it has a header. If you remember, I told you guys that we will have to put a field delimiter, and we will have to skip header equals to 1, because if I open the files, I'm going to contacts, and I'm going to open it with my Sublime. So if I show you, come on, if I show you on my Sublime text, you see, this is the file, right? We were trying to load. And on this file, if you see, there's a header, right? Now, this cannot be loaded into your column value. So we have to put header, skip header, right? That's exactly the thing which we have done. We have created a file format. So in Snowflake, you can create a file format and then use the file format while loading the data. And that is exactly what we have done over here. I have created a file format, which is my CSV format. Now, even though I have named it a CSV format, the field delimiter is 5 over here. It doesn't matter. And then the skip header equals to 1. Now, this is something which I've created. I'm going to create it again. That is why it is create or replace. Now, at this point of time, if I do ls, yes, the files are already there, right? It's already uploaded. Now, at this point of time, look at this statement. Copy into target table, which is contact internal stage, from internal stage slash contact1.csv. This is the first file that we're going to load using the file format equals to file format name. This is the syntax. Now I've copied this because this is what I copied from the documentation, and there's a, this syntax is very well available in the documentation, wherein they are copying into this particular stage from the first file and loading it. Now, if I execute this, please look at the output. Status is loaded. Rows parsed 5 because there were 5 records. Rows loaded, yes, 5. Error limit 1 because had it been an error, it would have failed on the very first error itself, right? These are the things. It's okay. We'll see when the error comes. It says, which line the error is in case there is an error. But in our case, there is no error. So that's why all 5 records have been loaded. Now, if I go back and do a select count star from this table now, I see there are 5 records. If I fire the second statement, another 5 loaded. Now, if I again go up and enter, I should be able to see 10 records. Cool. Now, there's a way to look at the status of the load programmatically, right? Now, at this point of time, what did I do? I went into the table and did a select star, but that may not be the right way. If I fire this, I'm surprised. There's that nothing came up. Okay. So they're saying that there is a way called, there's a command called validate. I don't know why is it not working now. So there's a command called validate. This is the syntax. Validate takes two arguments. The first argument is your table name, that it is going to validate um, the loading process, whether the loading process was successful or not. And it needs a job ID. What is a job ID? Now, every query that you fire in Snowflake is stored in Snowflake, and it is stored in Snowflake with an unique query ID. So if you go to on the left hand side, you see there is something called query history. If I go to query history, you will see all the queries that you have fired are here. Okay, all your queries that you have fired are here, and here is a query ID. Now, we fired this query, right? Copy into this thing. At this point of time, I'm going to copy this, go to projects, worksheet, and let's say if I, in place of job ID, if I place this, I'm supposed to get an answer. No, it is not working. That means something is wrong with validate. Fine. This is one of the ways to validate. We'll definitely come back. I'm not really sure. It was not working in the morning when I tried as well. So we'll look at validate once. Yeah, we'll look at validate. Why validate is not working. But you should remember that there are multiple ways to validate. Now, if validate is not working, not a problem. We can always go back to the table, the target table, the final target table where the data is supposed to be loaded. And we can query that and find out whether the data has been loaded or not. But this gives you the status of that specific copy statement, right? There is another way. There's another way. Copy into, give me a moment. There was a copy status. Yeah. Now, there's another way to find out the status of the yeah. Now, there's a metadata table called copy history. So guys, you will have to remember these things because they will ask you what are the different ways in which you can monitor your copy, because somebody is copying out the other. Now, the target table name in this case is contacts internal stage, right? So contacts internal stage. And if I run this, please watch out. There's a schema called information schema. Information schema is nothing but the metadata layer. So if you remember the 3-layer Snowflake architecture, wherein we had first layer was storage, second layer was the compute, and the third layer was the metadata layer, right? In that metadata layer, you will have, so information schema is nothing but a schema where there are multiple views which are system defined views. You cannot insert data in those views. You cannot modify the data in those views. If you see, if I go to a database, every database has this information schema on the left hand side. Even this Snowflake sample data also has information schema. Inside information schema, there are views. Views means non-editable data, right? So there are multiple views. This is all the metadata layer of the Snowflake, and you can only read that. So there is a way, there is a view called copy history. Let's go to the left and let's say whether there is a view called copy history. I'm sure there will be, right? Classes, no. Again, if you go to views, information schema dot, it's not showing up here. Why? Somewhere it will be application roles, classes, instance, load history. Yeah, there is load history. There will be something called copy history. Why is it not showing here? I don't know at this point of time. There can be many other views as well, right? Anyway, but this copy history is a view which has the history of all the copy commands. Now, it has all the copy commands, but this copy history takes few inputs. First is table name. You have to mention the table on which you are going to find out the history of all the copy statements fired on that table. It is not table, it's not agnostic of the table, it is specific to a table. Then you have to put the start time and the end time. So even if you don't put the start time, you see what it is doing? It is doing a date add. So again, date functions are very, very important. You will have to learn these things. So current timestamp always gives you the current timestamp. If I say here, select current timestamp, it gives you the current timestamp. Now, this is 7:26 in the morning because this is your United States time, right? Because if you remember, these accounts are all created in US West Oregon. Yeah. So this is the time of that particular region. Now, you might convert it, but need not do it right now. Now, what it is doing is it is taking current timestamp and it is adding -1 hour. -1 hour means it is the previous. So start time is current time -1 hour. So if the start time is now 8 o'clock, that means it is going to start time. Sorry, the current time is 8 o'clock. So start time is going to be 7 o'clock. So from 7 o'clock till now, it is going to give you the history. Now, if I run this, see, it shows you two file names. First, you loaded contacts 1, then you loaded contacts 2, the stage location, load time, the rows count, parsed, and the file size. So this is how you can find out the entire history of your data loading, right? Any questions on the internal stage? I'll pause for a minute and, if you guys want to, think about it again, think about it, what you just heard, and let me know if you have any questions. No? No questions. Okay, tell me, when do you think we should use an internal stage? Because I can use both an internal stage and an external stage. Now, based on whatever you have learned so far, or whatever data engineering experience, or whatever the engineering experience that you have, when do you think we should use an internal stage? Come on, guys. When should we use an internal stage? What do you think? Hanuman, what do you think? When do you think we should use an internal stage? Hanuman, you were there with us? Guys, can you guys hear me? I hope you are, right? So when do you think you should use an internal stage? And when do you think you should use an external stage? Because we did speak about internal stage and external stages, right? No? Fair enough. So internal stage is primarily used. See, this is again, they will test you in certifications. Internal stage is primarily used when you are, loading the data from your programs. So these data files are not having an external interaction. These data files are actually created as a part of your program itself. So let's say you write a stored procedure and the stored procedure is loading data into a table. And finally, the data needs to be, let's say, you want to store that data. You want to make it available for some other purposes. So internal stage is used primarily for storing data which are created internally, right? Any data which is generally created by the customer at all, everybody will try to put it as an external stage. Why an internal stage? Now, from a performance perspective, there can be a question that do you think because internal stages are internal to Snowflake, there can be a performance benefit if I use an internal stage compared to an external stage? Well, it looks like yes, but reality is different. Reality is no, it is the same because both internal stage and external stage are nothing but S3 locations in Snowflake, right? And as long as it is an S3 location, how does it matter? Because whether Snowflake uses an S3 or external S3 or internal S3, it is still an S3, right? So from a performance perspective, your internal stage and external stage, they're both the same. However, so if you write a program which is generating a file and you want to keep the file for somebody else or a later usage, now that file, you will definitely not send it out unless the user of that file is outside of Snowflake. If that user of the file is inside of Snowflake, you will still try to, keep that file within the Snowflake layer. So that's where internal stage comes into the picture. Fine. Now it is time for us to start talking about external stage. Yeah. Let's go to introduction to streams. I think we were talking about bulk loading. No, not here. No, no, no. This is, we were talking about external stages, right? Yeah, create stage. Now in stage, see, there's an internal stage which is stores data files internally within Snowflake. Internal stages can be permanent or temporary. You can create a temporary stage as well. References references data files stored in an outside location of Snowflake. That is what is your external stage. And now we are going to go and create an external stage. Now, guys, if you want to create with me, fine, fair enough. But I really don't know how many of you are, going to create it with me. But if you are willing to do that, you should start it. Yeah. Let's talk about an external stage. Now, to read data from an external stage, the first thing is you will have to create an object called a storage. 1 minute. 1 minute. Just switch on the light. Where is my C? Yeah, I'm back. So the first thing that you will have to create is a storage integration. Now here I have written some comments as well. configure a Snowflake storage integration to access S3. Please remember, in your certification exam, they will challenge you on the steps. What they will do is, they will write down 1, 2, 3, 4, 5, and they will tell you which is the right order of steps. So understanding the order of steps are very, very important. The first thing that you will have to do is create a storage integration. Yeah. And on my screen from line number 74 to 79, this is how you create a storage integration. Now, to store the storage integration is nothing but a bridge between Snowflake and your external stage, which is your S3. Yeah. Now, if you go to the documentation, you will see all of it. Huh? So if I, let's say, uh, external stage, and, external stage, there was some link URL. Yeah. So you can create an external stage. You can definitely create an external stage by using a storage integration, or you can also create by AWS key and secret access key. Now, just Google out how to get the AWS key and AWS for your account. You can get the AWS key ID and secret access key. But even though it is a possibility, nobody does it, because tomorrow, if you change your password, your entire project will collapse, because your project is actually dependent on this user key, right? Rather than that, we use the storage integration. Now, this is just a possibility. Don't say that you have done this, means you know it, that's fine. But if you say that you have done it in your project, they'll immediately question you that what happens when the secret key expires, right? Your entire project will start failing. So please don't use it. So next thing is storage integration in Snowflake. Yeah, this is the one I was talking about. So option one is, so if you look at it, look at this diagram. It's a very interesting diagram. So here is your external object, right? Here is your external object wherein you are storing your data as a file. Let's say a file in CSV. Now, here is your storage integration, which is reading the data from these files in S3. So this is your Snowflake on the left-hand side. This is your AWS on the right-hand side. This is the logo for S3, right? So you have data files over here. Now, these data files, to come and sit from this right-hand side to left-hand side, you need this integration, which is a bridge, right? And we will see how do we create the bridge. Now, before we create the bridge, the first thing that we will have to create is go to S3, create a bucket, and put some files, right? So if I go to my academy.demo, this is the file that this is the bucket that we have been using for quite some time, right? Anybody who's following with me to do it? If yes, then I'll go a little slow. Otherwise, anyway, I'll go at my pace, because you will anyway, watch out the recording when you are doing. Anybody doing with me? No. Fine. Fair enough. So I'll take the liberty to go ahead at my pace, so that you guys can follow, but I'll not wait for you to do it, because it takes a little more time if you're doing with me. But again, I'm okay to wait. If you think that you should do with me, please do with me. So there's an input folder called sample input, and within sample input, I have uploaded a file called contacts1.csv, right? So if I go back to my data, I'll lose this. Why is this open? Yeah. Data loading. Now I have to create the external integration. So my S3 bucket is ready. I have a folder, I have a bucket, and I have a folder, and within the folder, I have a file, right? Now the next thing is I have to create an integration. To create an integration, we will have to create an IAM role and IAM policy. Because if you remember when we were doing AWS, any service to service communication, whether it's AWS to AWS service to another AWS service, or whether it is one AWS service to another external service communication, it all happens through your IAM role. So for that, you will have to create an IAM role. If I go to my roles, you will see that there is a role called Snowflake AWS role, or a Snowflake role I had created, right? For the time being, we will focus on the Snowflake AWS role. Yeah. If I go to the AWS role, Snowflake AWS role, what did I do? I have attached a policy. Now, I'm sure you guys know how to create a role by now, right? So I'm not going through the steps of creating a role because the role is already created. So you can create a role, and in your permissions tab of your role, what you have to do is you'll have to add the permission. You'll have to add the permissions for attach policies. Now, if you go to attach policies, you will see this loads of policies will come. And what did I do? I have added the S3 policy, sorry, S3 full access. Or the S3 full access is not coming over here because the S3 full access policy has already been added over here, right? Amazon S3 full access. So your role is having complete access to your S3. Now, you will now question that, sir, why did you add complete access? Because it is only read-only. Yes, you're right. We are not writing any files as of now. But just to make things simple for us to understand, I've put a policy which is called S3 full access. You can put S3 read-only access policy as well. Now, fine, fair enough. What is the next thing? Now the role is created. So the role is having an ARN. ARN is nothing but Amazon reserved number, right? Amazon reserved number, they call it, right? Or Amazon, it's a unique number. ARN in AWS. This is the Amazon reserved number. Oh, Amazon resource name, sorry. Amazon resource name. So this is a unique number. Just give me a wait, just give me a moment. Just give me a moment. Yeah. So this is an ARN. So this is an unique Amazon resource name. So whatever you create in Amazon is an unique resource, right? So you have your Amazon resource name. So what you do is you go ahead to the screen, and if you see, I have put my resource name over here. And I have put the location from where to which I'm going to create that bridge, right? So storage allowed locations. So there can be a possibility of creating something called locations which are not allowed as well. But this is the first time we are creating it, so we'll not complicate things. If you go to storage integration as an object in Snowflake documentation, you will be seeing the different parameter, the different parameters that you can pass. So I've taken the bare minimum parameters wherein you can say the storage allowed locations. So what is the allowed location? Allowed location is academy.demo. Sample input is your allowed location and your ARN. Now, the moment you create this, you will be able to, you create a storage integration, right? So let's say I am creating the storage integration again. Yeah. Snowflake role. Oh no, I cannot use this. I have to use this. This was the other one. So I'm going to use Snowflake AWS role, right? Because we are talking about Snowflake AWS role. So if I go ahead and execute this, It's already created. And the name of this is S3 integration underscore 1. If I do a describe integration, what will you see? Whatever the integrations, there is something called enabled equal to true, provider equal to S3, allowed locations, S3 demo sample input, blocked locations, nothing. I did not block anything. Then there is an ARN of the user, ARN of the role, and the external ID. Because if you remember, we were talking about this diagram, right? This diagram. So there is an external integration. This is not AWS to AWS integration. There is an external integration. And that is why you need an external ID. So at this point of time, you see that there is an external ID created, right? So what we have to do is we have to go to our role. We will have to go to trusted relationships, wherein we can see under trusted relationships, there is this AWS principal. AWS principal is nothing but your user ID. What is your user? Guys, you'll have to be very, 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 very attentive over here, because it's a rule that you will have to follow 1, 2, 3, 4, 5. You cannot, hop from 1 to 5 and then come back to 2. No, it will not be able to do that. So you have to be very, very attentive in whatever I'm showing over here. So this AWS external ID goes and sits in your external ID space. And this is what I'm doing is not in the permissions. So permission is done. I've added a policy. Now the role itself has some relationships. Within that, in that trusted relationships, I'm putting the external ID, which is nothing but the external ID of your Snowflake account or Snowflake user. And I'm going to take the user ARN, and this user ARN, I'm going to put it here. Sorry. I'm going to put it over here. Only 1000 is, right? At this point of time, this is what is already done. So your Snowflake AWS role is now complete in a way. It knows on the right-hand side, it has snow with reference to this diagram. Where did the diagram go? Yeah. Now your Snowflake integration at this point of time knows that there is a role out here. Okay. There is a Snowflake role out here, which it needs to talk to. And the role is going to, connect this integration object to the bucket. And on the other hand, the Snowflake integration object can talk to our stage. That's exactly what is happening. So your role user ARN and your external ID. See, the role ARN will anyway be here, because during the process of creating the external integration itself, this one, external integration itself, you have given the role ARN. So the role ARN will anyway come. The user ARN has to be updated back to your AWS, and the external ID of Snowflake will have to be put back to your AWS. That's what is done, right? At this point of time, I'm going to create a stage. Yeah, I'm going to create a stage. You see, create or replace external stage. Now, create an external stage, you really don't have to name it external. I have created my S3 stage. I could have mentioned my external stage as well. But right now, it is my S3 stage. S3 means it's definitely an external location, right? URL is my academy.demo sample input. And using my storage integration S31. So again, going back, my external storage object is going to create, I'm going to create an external stage over here, external storage object, which is going to use integration 1. That's exactly is spoken about here, using integration 1. So if I do a create or replace, it's already created. Anyway, it's going to replace it. At this point of time, if I do a describe of the stage, you see all the properties of the stage are mentioned over here. If I enlarge it, means these are all the default properties that has come. If I enlarge it, you will see AWS role, external ID, I am I am integration, and the storage integration S31. It is already updated. Okay. At this point of time, let me go ahead and do ls. Let's see whether it comes up or not. Oh no, something's wrong. Something is wrong. What is wrong? No, something is breaking. Let us try to fix it. So what could have broken? This is created. If I go to my external integration Snowflake AWS role, let me create this role. Okay. Go to my description. Go to my description. If I go to the description, I should be able to copy this. I think maybe we need to update it. I'm not really sure. I'm going to edit it and I'm going to update this. Yes. See what happened? We did a create or replace. Now, every time you do a create or replace, your external ID changes. That's the only thing, right? The user will not change, but your external ID will change because you are creating your create or replace. That means every time it is overwriting and creating another Snowflake object of the same name, right? So that is why you have to come back and update this. Now, at this point of time, I've updated it. Username doesn't change. User remains the same. And if I go ahead and what happened? Integration does not exist. Come on. Still not working. Let me copy this one as well. Working that. I'm sure this is not changed. Same number 891 will come. Yeah, same number. Update the policy. Let me close this. Unnecessarily, so many windows are open. Right? This is open. I have to create a stage. Now I have to create or replace the stage. I have to create or replace the stage. Yeah. Now if I go and do an ls. Yes, fine, done. Got it, right? It was not working because again, I was skipping steps. So you should not skip steps and you have to remember the steps because they're going to ask you, they're going to try to confuse you that these are the steps. Tell me the right order. So it's like, they'll give you a bunch of steps and they'll give you some order of the steps and they will ask you, choose the right order. Okay. One moment. One moment. Ah. Cool. So now my external stage is created and I have also connected my um you know I've also connected my external stage to my actual S3 folder. And when I did an ls, I was able to see contact1.csv already uploaded. I'm going to create or replace another table right now. I think the table is already created, so I can very well truncate the table. If I do a select star. So now this time I have replaced int with ext, which is like an external stage. So contacts from external stage. It's a new table. Same definition, same files. However, I'm loading it into a new table, which is an external stage. Let's try to load. Please remember, again, the same type of statements. Copy into contacts underscore external stage. Previously, we were loading into a table called internal stage. Now we are loading into external stage from what is my external stage? My S3 stage, right? Because it is an external stage. Contacts one, again, the file format has to be defined because it is not a CSV file that we are having. It is a pipe delimited file that we are using, right? And in along with being it along it being a along with its property of being a pipe delimited file, it has also a header which we need to skip. If I use this, yeah. So it's like rows parsed, rows loaded, and error limit is 1. Now, if I go back, you see 5 records have been successfully loaded. Fair enough. So we were able to load data from an internal stage as well as an external stage. How did we load the data from an external stage? By creating an external integration, Snowflake external integration. Now, that external integration is one of the ways to connect or create an external stage. You could have also created an external stage by using AWS keys and AWS access keys, right? Like, for example, if you go to my IAM role, I'm user. If I go to users, no, I cannot go to users. Give me a moment. I'll stop sharing my screen for a moment. If I go to users, if I go to trainers, uh, if I go to users, if I go to create user, let's say test, right? Uh, yes. So this is something which I can show you now. Sorry for that because there's something confidential which I did not want to show because this is all getting recorded, right? That's the only reason. So if you come over here, I just went to the create user tab. You can also do it, right? Under create user, I have put test. Now, please remember, we need to create an user with programmatic access, right? Now, if you want to create an IAM user, it will ask for auto-generated password and passwords and everything. The moment you say next, it will actually allow you to download your secret access and AWS key ID um, in a CSV file, right? So, but please remember, once you create it, that's the only time you can download your AWS access key ID and key ID, or access key ID and secret. You will have to save it. Next time, AWS will not allow you to regenerate it. What you can do is you will have to delete an user and create another user. So that's only the limitation, and that's the reason why I did not want to show you. So that one. So using AWS access key and secret access is just know it that it happens. It's very easy because it's just like connecting to your database, right? With username and password. There's no integration object getting created. It's just username and password you created and you're done. But that is not how things work in real life, right? In real life, you will always be creating an AWS storage integration object. And with that storage integration object, you are going to connect your left and right. When I say left and right, that means your AWS and Snowflake. Right. Continue. Now, what is the next thing? So we spoke about What did we speak about? We see we are progressing very steadily, and I'm very happy with the progress. So we spoke about internal stage, we spoke about external stage, um, and now we will speak about. So we are done with bulk loading. Bulk loading will definitely be a part of the project that we are going to discuss tomorrow. And finally, we will have snow pipe. Now, what is snow pipe? I'm going to talk about a little about snow pipe, and then we will go for a break. Or you want to come back and let's do this. Let's go for a break. 8:30. We'll take a 15 minutes break. Um, you know, and then we come back and we will start with snow pipe. Snow pipe, because snow pipe is very interesting. It's going to take some time. Um, and then we will talk about streams as well. So today we will cover up the theory part of stream. Tomorrow we will cover the lab of stream, which is going to be super easy because streams as a concept is little difficult, but streams as a lab, it's very easy. It will not take more than half an hour to cover up the labs, and immediately we'll move over to glue. Okay, cool. Good to go for a quick 15 minutes break. Have a cup of tea and let's come back at 8:45 sharp. Okay, cool guys. Uh, Everyone in the meeting, we come back at 8:45. Okay, chalo. Think about it, whatever the things that we have studied so far. If you have any questions, again, guys, you have to think. If you don't think, your questions will not come. And if you are, and until and unless you are questioning, um, your horizon will not increase, right? So you have to ask questions. You have to first, and to ask questions, you have to understand it. Cool. See you at 8:45. Are you guys back? A quick show of hands. I can see only Somya is back. And everybody, how about others? Mona, Nikita, Kruti, fair enough. Cool. So now, any questions at this point of time? Did you guys got a chance to think about external stage, internal stage, application of these two? No questions? Okay, fair enough. So now we will start looking at snow pipe, right? Let's go ahead into the documentation for snow pipe. Yeah, so if I go to snow pipe documentation, so what is snow pipe? Guys, I'll send you the link for the documentation, okay? Please ensure that you give it a read. You have to read it. You just can't say that, I'll not read it, because maybe you will be able to implement snow pipe without reading this. But reading about snow pipe is very, very important, because of your certification exams. They will ask you about the very, very minute details, cost and everything. Huh? So to start with, Snowpipe enables loading of files as soon as they arrive in the stage. Yeah. Now they say the word as soon as, but it is not so. There's a delay of around 2 to 3 minutes. Yeah. So it loads the data for every 2 to 3 minutes. It checks. The moment the file is available, it will load. We will see that it is not. Why am I saying that it is not real time, and why am I saying that it is near real time? You will get to understand. See, micro batches. Now this is how the English language fools you, right? At one point it is saying micro batches, and the other one, it is at the other side, it is saying as soon as. So as soon as means it is real time, but it is not so. It is through micro batches. So please remember, it is in micro batches. How does Snowpipe works? Automated Snowpipe using cloud messaging. So as soon as something is loaded to your, or some files are loaded to your snow or to your S3, S3 creates a notification. Yeah, and that's what you are charged for. So there is an S3 charge as well, which creates a notification, and it lets Snowflake know that, hey, Snowflake, there is a file which has been loaded. Please load the file, right? Now, there is something called Snowpipe REST endpoints. Now, this is something which I do not have as a part of my demo yet. But yeah, you can try it, or just read it from here, because your client application calls a REST endpoint with the name of the pipe object and the list of the data file names. If the new data files matching the list are discovered in the stage referenced by the Snowpipe, they are queued for loading. That means you call the Snowpipe REST endpoint. So there is a concept called REST endpoint preparing to load the data. So I don't have a demo, or I think I missed this one. Preparing to load using Snowpipe REST API. I can show this to you in the next class, but yeah, means you can also explore this one. Yeah. Maybe take this as a little homework, and tomorrow you can let me know whether you were able to make REST APIs for Snowpipe working or not. Yeah, we'll see this, but for the time being, we will look at auto ingest. I think I missed it. Otherwise, I would have added this Snowpipe in my today's demo as well, right? Anyway, so here is the process flow for auto ingest. Auto ingest automating from S3 network traffic. Uh, Yeah, so your Snowpipe in the background will also use the storage integration that we created in the last chapter, wherein we were creating S3, external stage. Because Snowpipe in the background will all it's see when we uploaded a file to an S3 external stage, we were loading the data manually. Now here the difference is we are creating a serverless service called Snowpipe. It is definitely chargeable. Some credits are there. So there is a Snowpipe cost, as you can see on the left hand side. So there is a Snowpipe cost, but it is very, very less, very, very less. I think it charges you 0.06, uh, it charges you per core, something like that. 0.06 cents credits per hour, something like that. It's very less. Anyway, coming back to my older diagram, where is it? It shows how to create it. Yeah. So now what happens is you have your data files out here on the top. And then there is a continuous loading to your S3. So we will also do it. We will also upload one file after the other, and you will see that files will be consumed and files will be loaded. Now, you create a Snowpipe within your Snowflake environment pointing to a table, right? And which will fire the copy statement. We will see all that in action. But how will AWS notify the pipe that, hey, there is a new file? The way to create that notification is to create an SQS queue, which is a simple queuing service. So this is again a AWS service, which is called simple queuing service. So on your stage, on your S3 location, you will create an event notification, and that event notification will actually spin up an SQS queue in the background, and it will let the queue know that, hey, there is a file to consume, and the file will and the queue will pick it up. Yeah, this is what we will do. Now, for your REST endpoints, it will actually do the same thing. Only the difference between a REST endpoint and your automatic Snowpipe is that what is a REST API? REST API is nothing but an API, right? So if you don't know a REST API, please Google out and learn about APIs. So what if there is a requirement that you call a Snowpipe created within Snowflake from outside of Snowflake? So right now we are all within Snowflake. However, if the pipe is outside of Snowflake and you want to call that Snowpipe, how do you do that? That is all the REST API is going to do. It is just going to tell you how do you operate a Snowpipe from the external world using an API. That is something which we will see. If we get some time, we will talk about it tomorrow. But for now, we will limit ourselves only to the normal Snowpipe. So let's go to our loading window. If I show pipes, right? You'll see that there is already a pipe called mypipe_s3, which is created. Guys, if you look at these scripts, they're all from the documentation. The Snowflake documentation is so nice that you can there are examples taken from these are the documentation examples itself. So don't worry if you are I'll give you these scripts in any way. but the scripts are there available in your documentation also. Okay. So at this point of time, I have a pipe. So what I'm going to do is I'm going to recreate the pipe so that it reads from the beginning. For the time being, what I'll do is I will delete this file called contract1.csv. Let's delete this. Right? It's deleted. Now I'm going to create a pipe. Pipe is nothing but a serverless object. Now I can create the pipe through the script. I can also create a pipe through my UI. But again, UI means you should know how to create it through a script, because we are all programmers and we should be passionate about creating objects through scripts rather than the UI. To create or replace pipe, auto ingest is true. If you put auto ingest equal to false, that means you will have to invoke the pipe every time you call it. Auto ingest equal to true, as what is the definition? The copy statement. The very own copy statement which we utilize for external stage, we will use the same copy statement. Because that's the only way you can load your data while the data is loaded, while the data is in S3 location. So copy into my target table, external stage. So let me go ahead and see this 5 records. I'm going to truncate this. And it is truncated, right? So if I do a const, I'll get 0. So let's create the snow pipe once more. I have created the pipe at this point of time. If I say show pipes, what do I say? My pipe underscore S3. What is the definition? This is the same definition, which we just created. Owner. And here is a notification channel. What is a channel? The channel is, again, the channel refers to this piece. Sorry. The channel is actually referring to this piece. Where is the diagram? I'm losing the diagram. Yeah, the channel is actually this. It is like somebody has arrived, or some file has arrived at your S3 location. However, your S3 location is, your S3 location will have to communicate to the pipe. So that is what the channel is for. The channel is a method of communication. So it's a queue, it's a pipe. Incoming events will enter at one side, and from the other side, it will be processed one by one in a queue, in a series. If I go here, so I have the channel created, right? Now, what do I have to do? I have to copy the channel. I have to go to my S3 bucket. So in my bucket, there is something called a property. If I go to my properties, you will see there is something called an event, event notifications. Now, if you see that the destination is this, there's already an event created. However, I need to replace this with the new channel, because I did a create or replace. So that means I'm sure the channel name would have changed. So let's not take a risk. I'm going to go there and I'm going to edit this. How can I edit this? Yes, I can edit this. Oh no, it is not allowing me to edit it. Why? Can I not edit it? I think it is not allowing me to. Yeah, it is allowing me to edit it. You see, what is the prefix optional? That means prefix is nothing but the folder. So I don't want the snow pipe to come into action whenever a file got uploaded on my bucket. No, in a specific folder, sample it. Because if I am working on any other folder, it should not start. You can put a suffix, which is nothing but the your um, file type, which is .csv in our case. Let's put .csv. Yeah. Event, all objects, put, right? I'm not interested in a post. I'm not interested in copy or any other type of events. I'm just in a put. Put means upload. Anything else? Destination, it's not a Lambda function. It's not an SNS topic. It's an SQS queue. And this is where I am mentioning the name of the queue. I just updated the name of the queue, Snowpipe. That means whenever there is an event on that bucket inside that folder, this queue will be notified with an event. And I'm going to save the changes. Let's go back. If I'm going to do, so what is the status of the pipe initially? The initial status of the pipe is inactive. So let's say the status of the pipe. So this is how you check the status of the pipe. So there is a function called system $pipe status, and you pass the name of your pipe and in quotes. So that's what will give you the status of your pipe. So what is, oh, the status of the pipe is already running. The pipe is already running. And there is a, so if you want to make it to true, if you make it to true, that means the pipe will stop. The pipe is not operational. At this point of time, if I go ahead and say pipe status, you see, it is paused. That means the pipe is not working. It is possible that during system upgrades or, you know that there are no files going to come at this point of time, you want to pause it. Because it is a serverless object, you need not pause it. You are only billed whenever a file is loaded. So it is actually loaded per file. You are actually billed per file, right? Now, I will make it as false. That means pipe execution is not paused. Pipe is true. Refresh, I'll come to it. Refresh. Yeah. So at this point of time, your bucket, this folder, sample input, doesn't have any folder, any files. I'm going to upload a file. Let's add a file. Yeah, I just added a file. Succeeded. Let's go back and check the status of the pipe. It's running. You see, last pull timestamp is this. It is not coming up. It will take some time. Did it identify the file? You see, now it has identified the file. And this is what I was talking about, a micro batch. So when you have a lot of files, it takes generally 1 or 2 minutes for the serverless object to identify the file. If you read this, at the last, you see, last forwarded file path, contacts1.csv. This is the file I uploaded. And that is how it has automatically detected the file and it is loading. Let's see. Still one running. Let me go ahead and check the status of the pipe. You remember, we were able to check the status of the copy history. There was something called copy history. Now we are checking, we will check copy history as well, but we can check the status of the pipe as well. I think I'll have to make it minus 30. Huh? I don't know. Why is it not coming up? Let's go ahead and check the status of copy. Yeah. Copies tells you, I really don't know why is it not getting updated. I think it takes a little bit of time to get updated. Otherwise, it should also get updated on time. You see, contacts1.csv is the file that was uploaded. Rows count 5 and rows parsed 5, and the file size is 694. Now, at this point of time, if I go ahead and do a count start, yeah, you see 5. Here is the beauty. The beauty is, let's go ahead and upload another file. Upload. I'll add a file. I'll add number 2. And I'm going to do an upload. Now, if I go ahead and see my status of the file, I'm sure it will still tell me contact 1 because it has not identified it yet. See, last file path ingested and last forwarded file. Now, if I go ahead and execute it once more, it has picked it up. I'm sure it has picked it up. Last ingested file is 2 and last forwarded file is 2. Because it's a small file, I'm sure it would have got ingested by now. Lovely. You see, contact 1 and contact 2. Even contact 2 got inserted, 5 and 5. And if I go and check my record count, it's 10, right? So 2 files got ingested. Now, like this, I can push hundreds of files and it will slowly get loaded. Now, this is good for files which needs to be, means for near real-time data, but this is not enough for real-time data. That is where Snowpipe streaming comes into the picture. Well, I will show you streaming in action, but I'm not going to deep dive into streaming because streaming is not a part of your basic certification, which we are all talking about. Streaming is a part of your advanced architect certification or advanced architect certification. So if you want to attempt it, maybe you can learn it then. You definitely have to learn it then. But for the time being, we will see what a streaming is, but we will not deep dive because streaming is a very complicated subject. Don't try to take everything at one shot. Take one baby step at a time. Learn what is required for the basic certification, which is Snowpro Core. Finish it off, and then again, if you are interested, we can go for. We have a different batch. We have a different course for the advanced architect. If you enroll for it, we can take you through that advanced architect. But again, advanced architect is really difficult. It is always suggested that you at least have close to 1 to 1.5 year of absolute hands-on experience while working on a project, not just learning. In a production environment, in any customer organization, or in any customer floor, being a part of any organization, until and unless you have at least 1 to 1.5 years of regular experience, you will not be able to pass that, even if you study, because there are a lot of things which are purely based on experience. And most important is you should not even try to do that unless you are prepared, because the cost of the exam is going to, you will fall off from your chair now. It's $300, 25,000 rupees. So you will have to spend 25,000 rupees for that exam. And the worst part is, if you fail within 1.5 hours, 25,000 goes for a toss. So you have to be super, super prepared that before you attempt for the exam. Okay. Any questions at this point of time? Can I expect you guys to try out Snowpipe maybe tonight before you go to bed, or tomorrow morning sometime before you come for the class tomorrow? Because if you are not practicing enough, you will not have any questions. And if you don't have any questions, that means you are not learning enough. Right? So again, a sincere request, tomorrow morning, if you can spend some time. Definitely 1 hour is not going to be enough because you're doing it for the first time. Things will break. if things will make you cry, you're going to look up Stack Overflow, you're going to look up Snowflake community. By the way, there's a very strong community, community.snowflake.com. If you're stuck anytime, you can ask a question over there. Somebody or the other will help you. Yeah? Even today, if I get stuck somewhere, I do ask questions in the community, and somebody or the other helps us. So Snowflake has got a very core Snowflake user group. If you are stuck, but don't ask, very, very foolish questions. I have seen people giving very strong responses if you ask foolish questions. So try it out on your own. If you're really, really stuck somewhere, feel free to ask. Post your questions, and within 24 hours, somebody or the other will pick it up and will help you out. Okay. Now, we were talking about Snowpipe refresh. What is refresh? Let's go ahead and talk about it. No? Yes. So, what is refresh? The refresh statement copies a set of data files staged within the previous 7 days to the pipe. So what happens is, let's say you have a pipe, right? Or let me go ahead and create a diagram. I think refresh is something very important. You should know it. You can try it out if you have some patience, but ideally you should know it. So let's say I'll go to draw. So then you have a queue, right? Let's say you have a queue. Now, if I go with red, so you have one. So file number one, file number two, file number three, file number four, 5, 6, 7. So you have 7 files. Now what happens is, let's say you have ingested file number one, or rather, let me do it this way. Sorry. Let's think it in this way. So 1 is here, right? 1, 2, then you have 3, sorry, then you have 3, then you have 4, then you have 5, 6, and 7. So the files have all entered like this. So this is your input, and this is your output, which is your Snowpipe. So the first one has entered, second, third, fourth, it is getting processed. So first this will be processed, then this will be processed, then this will be processed, right? Now, if you remember, there was a command that we were looking at, right? Execution paused. So let's say all the files have been pushed, or rather 1, 2, 3 has been pushed. At this point of time, let's assume 1, 2, 3 has been pushed, right? And you have, and then you pause it. But you pause Snowpipe, but you are not pausing the ingestion of files. Files are still coming. 4 came in, 5 came in, 6 came in, 7 came in. And what you do is, then you again do a true, make it false. That means you are again restarting, or not restarting, you're resuming the pipe. If you resume it, what it will happen is the pipe immediately will go and check the queue. It will check, okay, fine, 1, 2. So it's like you're not deleting the history. The history is still there. So the pipe, you're just pausing the pipe. If you recreate the pipe, it will start from number one again. and your target will have duplicates, right? So that is when if you resume, and if you do not recreate, or if you do not delete the history of the pipe, what will happen is the pipe will remember that 1, 2, and 3 has already been loaded, and I have 4, 5, 6, and 7 are there already. So I need to process them, right? So Snowpipe has a history of its own, and that is why Snowpipe never processes one file twice. And this is a very, very important question in your certification exam. When people will ask you that, or you will be questioned on the fact that um, your Snowpipe has been paused. What will happen now after you resume, right? So this starting and stopping of Snowpipe is one of a very, very, very interesting question. So managing Snowpipes. So again, let me push the link to the chat, which is management of Snowpipe. Management of Snowpipe. Now, what is refresh? Refresh means load the historical data by executing earlier. So if you do a refresh, that means it is going to reload from the start. So maybe what happens is you load 1, 2, 3, then you pause it, you resume it, it picks up 3, 4, 5, and then suddenly you realize, oh my God, it has loaded all the data, but somehow I need to load the data again. See, Snowpipe is just a metadata reference. It is not the files itself. So the files are still there in your S3. However, you want this pipe to load all the data again for some reason. Maybe you have updated the data in the target, or your target data has truncated and you want to load it again. That is when you do a refresh. And if you do a refresh, it is as good as creating the pipe again. So refresh means you are uh, making the offset of the queue back to 0. So it is again reading from the 0th offset, and it is reading one after the other and doing it. So understanding refresh is a very, very important topic. Please read refresh. And if you want to try, you can try it. Yeah. Now, load history. As I said, load history is something Snowpipe stores the load history. So unless you do a refresh or you delete the history, Snowpipe will never process one file twice. You can have the same data within the file, which will make it load twice. However, if you are ensuring the fact that your files are not having duplicate records, it will always ensure one file is not loaded more than once. Okay. What else? Yeah, you guys can stake the stillness or property. So there are a lot of things. I don't think you need all of it um, for your certification exam, even to work with, to get started working with. So um, I think this should be okay, because given the kind of questions that I have seen that comes in the certification exam, this should be okay, and this is enough for you to start working on your projects as well. Now, we will talk about something else now. We will talk about, before I move on to streams, right? Before I move on to streams, this is what we are going to talk about. Before I move on to streams, any questions at this point in time? Any questions? Hanuman, you have been very silent today. Krishna, Kruti, Nakita, Ramya, Mona, Sejal, Soumya. No questions? You guys with me? Are you understanding? Or you want me to repeat any specific topic, or it is absolutely clear with you? Guys, you get there with me? Hello.
Yes, sir.
The rest of the class has gone into a hibernation mode. Hmm. Sometimes it becomes really difficult, or, you know, I always think that, whether you guys are awake, whether you guys are still there, because had it been in a classroom, I would have seen you guys. But here, we are also not switching on our videos because of the bandwidth things. I can't even make out whether you guys are still there in front of the laptop, or just because it is getting recorded, you know, mute yourself and then go and do something else. Anyway,
Available, sir.
got it, got it. But I'm little surprised because this is a very, very complex, very, very interesting topic, and you guys are not having any questions. Anyway, now the next thing is streams. So what is a stream? Stream in Snowflake, let me see. If I have any, let's go to Snowflake streams. I'm just going to the documentation so that you guys can also go there. Introduction to streams. Yeah, stream is like this. CDC. Is there any diagram to talk about streams? Uh, this is no diagrams, right? Fine. No worries. We'll do our diagram and we will try to understand what is a stream. Hmm, what is a stream? Draw home. Where is the pointer? How do I get my pointer back? I was drawing and now I will. Oh, yes. Yes. We are at 9:26. We will quickly finish two or three theoretical subjects and we will wind up for the day. It's been a long class. I'm talking for a long time now. After speaking for an hour continuously, your mouth becomes dry. It's like, that is why I always sit with a big cup of coffee, which I heat up 3 times during the class and keep sipping. Otherwise, anyway, so we were talking about strings, right? So let's say there's a table. Yeah? There's a table. We have a table, and the table has some rows. This is, let's say, hour one. Okay, this is hour equals to 1. Now on hour 2, let's say few more records are getting added. Possible? And at the same time, maybe, uh, let's say, uh, yeah, let's say, at the same time, there are multiple columns, right? Let's say it is an aggregation of, let's say, 10 columns are there, right? In hour 2, it is possible that some record over here, you know, got updated, some record over here got updated, and some record over here got updated. Now in hour 3, let me take a pen like drawing mode, pencil. No, not a pencil. Let's say this, yeah. Now, let's say hour 3, some more got added. Sorry, where did I lose it? Yeah, some more got added, and at the same time, some more got deleted. I'm deleting this, right? Maybe I'm deleting this as well. So you can understand that over a period of hour, or it may be hour, minute, or second, or day, or month, anything like that. So different time, there's a change in a table. So if this is one table, so let's say I put it as this is table T1, so many changes have gone place. First time, they were all inserts. Second time, they were inserts and updates. Third time, there are inserts and deletes, right? Now, this is called, now, if you want to capture all the changes that has happened on the table, you have to create some called a CDC, which is called change data capture. Now, when we started our career in 2006-7, what happened was there were no uh, tools as such to do CDC. We had to write our query to find out the changes. So it's like, we always had to query the table and find out what has changed. Has there been a delete? Has there been something? And it is a very, very lengthy process because you have to check the whole table. After some time, after a few years, IBM came back with a tool called CDC. They named the tool itself CDC in line with the concept change data capture, and it was a very, very there are few companies who still uses it. It was a very costly tool and a very useful tool which helped us to identify the changes. In Snowflake, there is a concept called streams, which helps us to identify the changes. And if that means, how does streams work? So if I rub this, if I rub this out, how does streams work? Right? So if I have a table, T1, I have a table. Yeah, I have a table T1. And I'm configuring a stream. So stream is also an object. ST. It is streams. No? I'm configuring a stream, and stream is like, stream is neither a table nor a view, but you can still query a stream. Okay. So what happens is stream is always listening to T1, and streams always follows T1, that what all the things which are getting inserted and what all the things which are getting updated. How? If I go to my documentation again, offset storage you understood, right? In the previous, this is from a very common understanding of a queue. So here is a current time and there is a source table. Read about it, you will understand. Yeah. Now what I was trying to tell you is, yes, there are three columns in a stream. One is metadata underscore action, metadata underscore is update, and metadata underscore row ID. See, there is a call. So in your streams, if I, where is my PPT? So what happens is, if this particular table has 10 columns, stream adds +3 in the stream view. And these three are these columns: metadata underscore action, metadata underscore is update, metadata underscore row ID. And by querying these three, what is the action, is update or not, you will be able, streams helps us to understand, is there an update, is there a delete, or is there an insert, right? Based on these three, we can, if we query the stream, we can find it out. Now, it is very, very important because I need not query entire table one. I can just go to streams and find out which are those rows where the action is insert, huh? Or the action is delete. Now for update, there is a different one. If there is an update, I'll pick it up. So I'm going to read only those records from the stream where there is an update or where action equals to insert, right? I can always do that. Types of a stream. So you can create streams. Again, there's a standard stream, which is like, which works on all type of objects. And there is an append only stream and there's an insert only stream. So a stream which only accepts inserts, and a stream which accepts uh, you know mm, it only append only. But overall, the concept of a stream remains the same. Stream tracks changes on your source table, and it has to be only one table. Stream tracks changes on your source table, and stream identifies whatever the changes that has happened in your source table by using these three metadata columns, which are like 1, 2, and 3, right? Now, let's look at an example. There's a, and there are, please remember, there's also a retention period and staleness. So I'm again sharing this information on the chat for you to read it. Please read through these English context, because just understanding is not going to help you. Because in your certification, see, from a work perspective, project work perspective, yeah, just understanding is okay. But I experienced that during the process of certification, what they will do, they'll pick up sentences from these texts. It's like, this restriction does not apply to streams, directory tables, or external tables, whether this is a true or false, right? So even if you understand, it's okay, but along with understanding, you need to read it at least once. Because the stream that you create over here, it will have a retention. The stream, it's like, you cannot say the stream is going to track changes forever. No, because the stream has limited size. So for that, you will have to be very mindful about the retention period. Now the default, I think the default retention period is 14 days, but you can lower it. You cannot increase it, but you can lower it. What else? What else? What else? Yeah, we will look at all of it tomorrow. But for the time being, there is another concept that we have to learn. And this is very important for our project. So did any of you read about data warehousing after the last 1 or 2 classes wherein we discussed about data warehousing? We discussed about facts and dimensions. If you remember, I'm sure you guys were there in that class, right? I think we discussed about data warehousing in 3rd or 4th class. I don't remember, but anyway. So there is a concept called, can anybody, tell me, when do we call a table a fact and when do we call a table a dimension? What is the difference between a fact and the dimension? Anybody? Guys, we are on the 13th class. This was done on the 3rd class. So I'm expecting that you guys are, you remember something, right? No? Completely blank? What is the difference between a fact and a dimension? I'm sure some of you are Googling around and trying to find out an answer. But yeah, that's also okay. Once Google out, find out an answer and tell me what is the difference between a fact and the dimension. No? Hmm. Now, what do we do? We will talk about. So I'll not give you the answer. You have to figure it out yourself. Okay. Um, so we have our facts, right? We have our facts and we have our dimensions. Now, under dimensions, there is something called SCD1. Then you have SCD2. Okay. Then you have SCD3. What is SCD1, 2, and 3? Right. I'm not going to confuse you with 3. You will read about it. Okay. This is something you have to read about it. I'm going to tell you about 1 and 2. And why am I telling you? Because this is what, anyway, we will be discussing tomorrow. But this is a part. It's good that we are discussing today itself, because this is what we would have discussed um, tomorrow during our project. But it's good that we are discussing now SCD1. So now let's say you have a table. You have a table wherein you have, let's say this is name of a person. This is age of a person. Yeah? And this is location of a person. Name, age, location. This is NA. This is AG. And this is LO. Now let's say the person's name is P1. Age is 10. Location is Delhi. Okay. Location is Delhi. And this person stays in Hyderabad. And this is 20. And this is P2. Right? This is snapshot 1 of the table. Now what happens is, tomorrow the person moves from Delhi to Chennai. CHN. The person moves to Chennai. You see, what happened is I'm updating the record. So that means I'm not creating duplicate record. I'm not creating history. I'm creating only one record which will show the current location of the person. This is called slowly changing dimension. Please note this point and do some research. Read about it, because it is very, very important. Okay? Slowly changing dimension. Now, let's say I am taking another scenario wherein I'm going to add a date, dt. Okay. And what happens is, take the red pen. This is Jan. Okay. P1 started living in Chennai from Jan, and P2 started living in Feb. Okay. P2 started living from Feb. And I'm going to add one more record over here, which says current flag. And for that, this is true. And this is true. Now what happens is, P2, this is in the month of April, right? What happens is, let's say I take this. Now, P1, age 10, from Chennai, he moves to, let's say, Coimbatore. I don't know the short form of Coimbatore, but let's say COB, right? or let's say it is Coimbatore. Okay. And what is happening? Mouse, right? COB. Now, when did he move it from? He moved from, let's say, April. Yeah, APR. This is April. Okay. Why suddenly my handwriting has gone for a toss? Let's say it is APR. Okay. Now, what will happen is this will become true, right? And this will cross. Correct? This will become F now. This will become F now. This will become F now. And this will become true. Correct? That means I'm creating a history of change. And the moment I create a history of change, that becomes my type 2. Correct? Now, these are the two types of dimensions. Please read about it before you come tomorrow. It will hardly take 15 minutes for you to browse or to Google around, Google up what is a slowly changing dimension and read about it. The reason is tomorrow we will discuss about how to create a streams, how to create a slowly changing dimension using streams. And that is what will be a part of our mini project. Are you able to connect what I'm trying to say? What I'm trying to say is, let's say you are receiving files from your S3 location, and your job is to feed the data into an slowly changing dimension. So every time you get a file, you have to get the files, and you know what all the things that has been added to the file, updated in the file, right? Now, whatever the inserts are there, those inserts will straight away go and sit in your target, will straight away go and, where is my mouse? Yeah, will straight away go and get inserted in your targets. However, if there is an update, right, the updates will have to follow this. First, it has to go and close the previous record. That means if the previous record, if the for a primary key, right? Definitely for a primary key, for a given primary key, if there is a record present, it has to first close it. That means it has to first update the current flag to false, and then it has to insert the new record. And that is exactly called a merge statement. There is something called a merge statement, right? Insert statement. So merge. I want you to read about SQL merge tomorrow before you come tomorrow, because I'm going to ask you. Okay. So SQL merge. Now, what is a merge statement? Merge means it will do insert and update together. It will, wherever it will find a match, it will do an update. Wherever it will not find a match on your primary key, it will do an insert. Merge is sometimes very equivalent to upsert. So there is something called update, and there is something called upsert. Now, because this is very basic SQL, I'm not going to teach you this. If you already know this, fair enough. If you don't know it, please read it before you come tomorrow. Okay, because this is what our mini project will be. We will be getting data from some files. We will get it. I really I don't have the files with me yet, but I'll figure out. I'll download some files from the internet. I'll give the files. You will have to, load the files into uh, using Snowpipe, definitely. Then there will be streams, because the moment the files are loaded, you will have to look for duplicates, if there are any duplicates or not. And then finally, you will have to create slowly changing dimensions. Okay, so that's going to be the job for tomorrow. We will review it in detail tomorrow. And as I told you, in the next class, sorry, not tomorrow, we are going to review streams, and we will review the remaining part of glue. Um, and next week, we are not going to have our classes. They will be, doubt clearing sessions, or I'm going to assist you. Now, again, don't come and tell me, sir, this code is not working, right? My help for you will be all conceptual. I'm going to give you material, I'm going to assist you in understanding. But from a coding perspective, if something is not working, you have to Google out and fix it out. Guys, you will have to learn it. It is not that I don't want to help you, but if I give you a code as a help, you will never be able to learn. You will always think that, okay, man, the moment I'm stuck, somebody is going to give me the right code and I will be through. No, people in your organization will always give you information. People will always give you assistance, but that assistance will always be conceptual. Nobody will come to your desk and code it for you, right? So if there are any questions, means if you come and say me, so this syntax is not working and this is not working, I'm going to help you only conceptually. I'm going to give you, maybe I'll route you to the right documentation, but I'm not going to show you the code. And that's something which I'm going to not do for anybody, because you should be able to do it. You should be able to Google out the answer, and finally you should be able to do it if you are stuck, right? That's where we are. So please read about merge, update, and upsert tomorrow before you come, and also read about SCD. It is about slowly changing dimensions. SCD, 1, then you have 2, then you have 3. 1, 2, and 3 are, it's like, read about 3, you know, find out. These are all very, very core data engineering concepts. You must know it, because whether you are a Snowflake expert or a Databricks expert or a Python expert, doesn't matter. This is like, so whether you do your engineering in computer science or whether you do your engineering in mechanical or electronics, in the first year, everybody learns mathematics and engineering drawing, right? It is like that. Whatever you do, whatever programming languages you know later, but if you are a data engineer, you have to know SCD type 1, type 2. You have to know merge, update, and sequence upsert. Okay. So I don't have anything else for today. I'll leave that to you to study. And tomorrow, um, I'm going to pick, because I have seen, if I ask, nobody answers. So I'm going to pick on some of you, and you will have to unmute yourself, and you will have to give me. You will have to explain a little more on SCD type 1, type 2, type 3, merge and upsert. Okay. Fine. I don't have anything else. Good that we have finished whatever I wanted to touch upon today. Now, I don't want to start with streams today, because I'll not be able to finish in next 10-15 minutes. The lab part of streams, right? We all looked at the theory part of streams. The lab part of streams is something which we will look at tomorrow. So we have looked at internal stage, external stage, Snowpipe. Snowpipe REST API is something which we have not looked at yet. I'll see if tomorrow, if I get some time, I'm going to prepare something for Snowpipe streaming. Sorry, Snowpipe REST API. Otherwise, maybe we will do it later. Because Snowpipe REST API, from a question point of view, I have never seen any questions Snowpipe REST API in any interviews, because it's a very new topic. But anyway, it's good to know. You should always know it, that if you want to trigger Snowpipe from outside of Snowflake, how do you do it? Because there's a REST API. Fine. Before we end the class, any questions? It is very surprising that there are no questions. All clear with everybody? Can I expect you guys to review the four concepts which I wrote on the board tomorrow before you come for the class?
Yes, sir.
Yeah, please read about it. And yeah, so let's end the class here. If you have any questions, I'm going to stay back for another 5 minutes. If you have any questions, you can unmute and you can ask questions. However, if you are done, means if you do not have any questions, you are happy to leave. Quickly go and have your dinner. And then if you have some time tonight, please spend reading about SCD type 1, type 2, type 3, merge, update, and upsert. Okay, I'll stop the screen share. I'm going to stop the recording and I'm going to wait for some more time.